I had started to see people around me coming out of grad school getting these jobs where their title was data scientist. And this is back in the bad old days of data science. I'm like, data science? That doesn't make any sense. Doesn't all science have data? Like this is that era where like this sounds fake. What are you saying? And I'm like, what are you doing in these jobs? Like, what are you doing? And they're like, well, we write code to analyze data, and then we write up, make a lot of plots, like explain like what the data is doing, and like communicate about the data, help people build models. And I was like, that was like my favorite part. Like that was what I loved to do back in like my research days.
Welcome to the Astronomers Turned Data Scientists podcast. I'm Joseph Ahern, one of the co-hosts, and I've been a data scientist for 3 years now.
And I'm Jeff Silverman, the other co-host, and I've been a data scientist for 8.5 years now. And coming soon, I'll have to round that up to 9, but I got to calculate when that happens. And our guest today is a longtime friend of Astronomers Turned Data Scientist, Julia Silge. Hi, welcome, Julia.
Hello, thank you for having me. I have been out of astronomy for roughly 18-ish years, but I have been working in data science, either as a data scientist or a tool builder for data scientists, for about 10. I actually exited and then kind of did some random things before I kind of landed in data scientists. But I've been in the world of data science for 10 years.
Awesome. Can you start by telling us how you got into astronomy?
Sure. So my undergrad degree was in physics, and I did love that. I think in hindsight now, where I am in my career, I do think that some of what my some of the constraints and or motivations I had to choose physics were not entirely based on reality. Like, I was 17 years old or whatever, but I had a little bit of an anti-engineering bias. And I think now, based on like what I do, I'm like, why? That didn't make any sense. I should have, like, why didn't I go into one of the engineering disciplines? Because it turns out, we may talk about this, but I really do like very applied work. Like, I am happiest when I'm doing very applied work. But I landed in college as a physics major. I actually was going to get certified to teach high school physics. That was my plan, kind of about the first half of my undergrad degree. And then I got interested in some research projects and did really well in my physics degree. Like when I would look around at my cohort, I'm like, actually, I'm doing really well. And not that that's not a reason to go be an excellent physics teacher, but I was like, well, maybe like what are the opportunities out there? What are the things that I could do out there? And did a few undergrad research kind of experiences. And so I would say, kind of at the normal grad school time, I was deciding where to apply. And I did apply to about half physics departments and about half astronomy departments. I was interested when I was applying to the physics departments, they were largely places where I would have done optics work, like an ocean optics place and like some of the sort of like, fancy modern optics, again, very applied programs. But some of I kind of through classes and research experiences I had as an undergrad, I got very interested in that area. And so I was kind of like, well, do I want to do like straight up optics kind of program, or do I want to maybe do astronomy, astrophysics, something like that? So when I was visiting where I got accepted, I loved the environment of the astronomy departments that I visited and met people at much more than the physics departments. And I think that I would still say that now, I think astronomers compared to physicists, astronomers, I mean, we're really splitting hairs here, right? But if you're gonna compare the culture of your average physics department with the culture of your average astronomy department, it tends to be people who do very applied work, very interested in applications of the kinds that you're talking about, the kinds of things you're talking about. I really saw it as a good fit. So I do not have one of the stories. I was a child and I looked up in the sky. I don't have one of those stories. I kind of landed in physics, decided I wanted to go to grad school, and then applied to both, and then decided to choose astronomy program. So I landed at the University of Texas at Austin, and I was there from 2000 to 2005.
Sweet. So we've had, a good split, I think, between the like you were referring to, people who looked up the sky and, fell in love, and that's definitely my background. But we've had a number of people that have come into sort of the physics astro type stuff academically in a variety of ways. So that's always fun. Okay, so you hinted at this earlier. So you're finishing up grad school and you end up doing a variety of things before moving into data science, as you said. Uh,
I
so
do.
so I'd love to hear, we'd love to hear a little bit of sort of how you made the decision not to kind of continue on that academic path, and then sort of what did you do in that time?
Yeah. So I didn't immediately exit. I did go to
Ah,
a postdoc. So I
okay.
went to a postdoc at Yale after I came waiting for University of Texas to Yale as a postdoc, working back in a physics department, but on an astronomy, on an astronomy project. And when I think about that time as a postdoc, that is what, okay. When I think about my time in grad school, I was legitimately happy in grad school. I liked my advisor. I liked my project. I liked my department. I really did enjoy the day to day of what I was doing. In my postdoc, I would unfortunately would not be able to say that was necessarily the same, both in terms of the work environment, both in terms of the project. And I would also say coming to terms with actually what does a career in astronomy truly look like? Like, what does it actually look like? Like kind of seeing these very large projects where people are like a little cog in a big machine, less autonomy than maybe I thought, like people in academia had, less like being able to have a big picture view of the kind of things that you're working on, seeing how slow things were, and so I start to kind of lose. I'm like, I really was quite happy all through grad school. Like I was like, no, I love it, this is for me. And for me, I was in postdoc, I was like, I don't know that this is for me. I also I got married kind of in there, and have a spouse who, it was we successfully got two jobs in the same place one time. That was us moving to Yale, and it was so awful and so stressful. We're not too so he's a physician, and they have like a match system that, so it's like the worst of all worlds. Like if you have two astronomers, you can sometimes swing something, right? Or and actually if you have two physicians, they have whole situations where you want to match together, but like doing it cross disciplinary, it was terrible. It was terrible. And I was like, I'm not very happy. I don't want to try to do that again. I'm not sure that I see a path realistically forward that I would be happy in. So that is the stage. So I left during that postdoc, is when I left academic astronomy, research astronomy. And then I was on a little bit of a random path for a while. I tell you, I taught as an adjunct for different universities around where we lived. We were then kind of continuing to move in that like early adulthood career time for my spouse, and I'm kind of like, all right, well, I guess I'll teach in this new city where we are. And I eventually worked at, because of a fellow astronomer like bringing me in, I eventually worked at an ed tech startup developing content for higher ed physics and astronomy classrooms, so like interactive homework kind of situation. I did that for a while. That company was acquired, laid me off, rehired me as a contractor, and I was like, this sucks. I think I gotta do, like, I don't want that to happen again. That was very bad. I did not enjoy that experience, the one of being like laid off and trying to find a new thing to do. And so that was really my motivation. I had started to see people around me who were at this point 3 to 5 years behind me from grad school, were coming out of grad school, getting these jobs where their title was data scientist. And this is back in the bad old days of data science. I'm like, data science, that doesn't make any sense. Doesn't all science have data? Like this is that era where like, this sounds fake, what are you saying? And I'm like, what are you doing in these jobs? Like, what are you doing? And they're like, well, we write code to analyze data, and then we write up, make a lot of plots, like explain like what the data is doing, and like communicate about the data, like about results, help people build models. And I was like, that was like my favorite part. Like that was what I loved to do back in like my research days. Not, I definitely have always loved teaching as well, but I was like, that was the part that I really liked. I was like, that's a job now? Like, what? Tell me about this. Tell me more about this. And so it was kind of at that point. So I was underemployed, like they had rehired me as a contractor, but I was underemployed. And I kind of took 6 months to be like, to take every MOOC that exists. This was back in the era of MOOCs. Do those still exist? Do people still take MOOCs? This is all like 10
I
years
haven't
ago.
I haven't heard that term in a while, but yes, I think they might exist still. But yes, massive online open course, right, is what that
Yes.
stands for.
Yes. Yeah. So I took like 6 months. It was like, okay, what do I need to do to try to get a job as a data science? Given that I was not coming straight out of school, I kind of had I'm like, I think my resume is starting to look weird. Like I'm worried, So I was like, what should I do? What should I do to try to like make this transition?
I'm aware that there are several people in the astronomers turned data scientist community who have passed through University of Texas at Austin at some point. You might have been there a little earlier than others, but I wonder if there's something about graduate school there that helped prepare you for data science specifically.
That's a good question. I had a great experience there. And I think part of it was that so it's a very observational heavy program. Like there are theorists there, but it's like, it's very observational heavy program because you actually have a high degree of access to telescope time when you're there. And so you have quite a big proportion of people who come through there who have like they collect their own data, like literally go to the telescope, collect your own data, and also instrument people as well. I feel like the instrument people who left academia did kind of go more towards an engineering role, but that sort of big chunk of people who did observational astronomy, I do think that's really good training because you have I would say the majority of the real data science that happens in industry is not really classic scientific method, A/B testing, randomized clinical. You're usually having some kind of observational data, and you need to use all these skills, all this understanding of like what is selection bias. Like you have to use all that to be able to say how can we understand the data that we have? What questions can we use to like what questions can we answer with this data that we have? Can we use this judgment that has been honed by these experiences and this training, right? So I think it is because I do think there's something there, and I think it is related to how applied that department is in general, and I think to how observational that department tends to be. So I think that is what I would attribute it to.
So you talked a little bit about, taking the MOOCs and doing, a lot of self-study at the time to build up, data science related skills or fill in some gaps there. Um, how did you go from sort of that to the applying piece and interviewing and learning that? Was it just trial by fire, or, did you have a couple of people that you knew had made that transition that you're kind of leaning on, or, sort of what was that aspect like?
Yes. Okay. So I applied to a handful of like boot camp type things because that was a thing back then too. Also, I think something that's not really. I got rejected from all of them. I got rejected from all of them. I I was like, okay, what am I gonna do? Like what kind of steps can I take? I pictured myself applying to jobs in the city where I live is what I was picturing myself doing. And so I was like, okay, what do I need to do to be able to get interviews at all and then be able to kind of like speak substantively, like have evidence that I can do this job. And I decided, not as one of the first people, but to ever do this was like, okay, I need to make a portfolio of data science projects, and I need to prepare them in such a way that they're convincing to people that this is like this person has substantive skills in this area. I can see this person come and working. And then I was picturing, sitting in an interview, and it was like something for us to talk about. You know, it's like, oh, I see you did this project. Tell me how you know, I was picturing that. So I started doing, I at the time, and I still live in Salt Lake City, Utah. And so I found kind of the public data portal for the state of Utah, and I picked a few kind of interesting things that were interesting to me, and started putting together a blog, like a data science blog. And if you my blog still exists, and if you go to those like really early posts, they're all like Utah centric, like data that, and I feel like some things that I did right about those really early blog posts was like it was not like super cleaned ready data. It was real data, like from the state of Utah, you know. Then so I think that was something that I was like, there's a lot of things that I'm like, oh gosh, embarrassing. But when I think about the things that I'm like, yeah, no, that would be what I would want to see now as someone who hires, you know, I was like, no, it's like real data, and then, you know, narrative intermixed with visualization and models, and like let me demonstrate like a fairly sort of realistic thing you might do. So I'm putting this together. I do get a couple of interviews for local companies that honestly did not go well. Did not go well. And so I'm like, okay, I'm like, what am I going to do? What would be the next thing that I could do around this time? I start also blogging about other kind of non-Utah things, like things that are the other interests that I have. And I have always been a reader. I've always been someone who reads a lot, who loves books. And I started doing some like text analysis blog posts around, like, I think the first couple I did were because what motivated this was I found Project Gutenberg, and I'm like, oh, you can get like the whole text of like books that are in the public domain here. And my favorite author is Jane Austen. I'm a huge Jane Austen fan, have been for, since I was like 12 years old. And so I was like, oh, look, I can get the whole text of these Jane Austen books and do various kinds of analysis on the text to emphasize this is like 10 years ago, right? So this is like, this is pre-LLM. This is like a long time ago. Old timey text analysis. So I do some of these things, and I had originally started doing some things in Python, and then started doing some things in R, and I started doing some text analysis in R, and then like basically on the basis of those blog posts, I got invited to this unconference, which is kind of like a hackathon style thing. It's like they invite people to come, and people don't give talks, but you kind of sit around and like make projects or whatever. So I was in basic. So on the basis of some of those early blog posts, I mean, I am super thankful. I was invited to this thing, and like changed my life. Like changed my life. So I went to this unconference and met a handful of amazing people. So this particular unconference was put on by R Open Sci, which is a really cool organization. If you're more of a Python person, there's also Pi Open Sci, really interesting organizations who support open source software for scientific computing of various kinds. So there's this R Open Sci unconference, and I met a bunch of amazing people. And one of the people I met is this person named Dave Robinson, and Dave said, like, hey, I saw those blog posts you wrote. Really cool. What if we made an R package, so like the equivalent of like a Python, but let's make an R package that makes that easy for everyone to do, instead of like writing out the whole, like all the functions yourself. Like let's package them up so that like people can install them easily and use them. And I was like, okay, sure. I've never done that before. And so we started a package during those 3 days, and it was on CRAN, which is the central, so the equivalent of PyPI. It was on CRAN by a month later. And then by a year later, we written a book published by O'Reilly. It was like it just changed my life, So it was during that process, I was still looking for jobs. And instead of getting a job locally here in my city, I ended up getting a remote job. And it was with someone who saw the value of the open source work that I was doing. So like saw the value of like being able to build package code instead of just being someone who writes scripts. It's like, no, you're someone who can develop packages, someone who saw value in being able to write about packages, being able to write about like how to do all these things. So my first job, where my title was data scientist, was at a pretty small consulting firm who the clients were all state and local government departments or NGOs who needed to do statistical reporting for compliance purposes. So they would have some program, right? Like picture a county putting into place some program, and they're like, okay, we need to show for compliance purposes how much difference it made to this population. And so it was a lot of like diff and diff kind of analysis, a lot of like, how can we tell if this made a difference, that kind of thing. So that was actually how I actually got employed. How I actually got employed as a data scientist was through, I would say, the real thing that made people take me seriously was my open source contributions.
Yeah, and I mean, the open source contributions, you hit on a ton of, skill sets and things that we always suggest to people, having that online portfolio project, whatever you want to talk about, writing, right? The blogging, the writing to a non-technical audience about the technical stuff you're doing, that's incredibly powerful. The networking aspect, I mean, you got this invite, but you went and you participated and you were networking at this unconference. But the other thing I wanted to call out was, having a full-time remote job back in
Yeah,
pre-COVID pandemic days.
2015. Yeah, yeah,
Yeah, that
yeah,
is
yeah.
that is non-trivial. That was pretty rare. It's certainly become more rare and then a little bit less, some back to the office kind of things. But yeah, so that's really interesting. That's pretty cool.
Yeah,
Yeah,
I've
Joseph.
actually
Yeah.
never had a job here in Salt Lake City. I don't
Oh,
know.
that's
I don't
funny.
know. I think I probably could get one now, probably, but yeah, I worked for that nonprofit consulting firm, and then after that I had a remote job. I worked for Stack Overflow for a handful of years, and then after that I came to my current company where I've been for 5 to 6 years then, which is also fully remote. And I think I don't know. I don't know exactly what it means. I don't know exactly what it means that like people I'm not compelling to people in my city. It's complicated. It's complicated, but
Yeah,
certainly I have been happy to work remotely this whole time.
yeah. I have, I think, four, maybe five data scientist friends living in Salt Lake City, and I don't think any of them work in Salt Lake, or they
Yeah.
work remotely for companies outside Salt Lake City. But
Yeah.
um,
Yeah, yeah.
I I am curious to hear a bit more about comparing the consulting role to some of your other roles, because I know we've had maybe a couple people that did that for a little bit, but I don't think we've dug too much into that in the podcast. And I've recently started consulting role, so I'm actually curious to learn as well. So I would love to hear more about that and how that compares to the more traditional, standard full-time employee type things.
Yeah, so I wasn't consulting for myself. I was working for a firm that like the clients were all these sort of different
Gotcha.
organizations.
Yeah.
And also since they were also mostly kind of in the nonprofit space, government and nonprofit space, it was not very large data. It would be mostly spreadsheet size data, but the use of the like why my title was like data science, like why we called it doing data science was because it was fairly statistically serious analysis of the data. So things that you wouldn't necessarily typically, probably someone can do them in Excel, but you wouldn't typically do them in Excel, right? Like you need a scripting language, like you need statistical like better statistical tools to be able to do the kind of analysis or to be able to give the answers they needed to do. We were using, not spreadsheet tools, but like code based kind of tools. So I worked on like survey weighting. Like you have a survey, say, of people all in a certain county, right? If you have like people have responded to a survey about some services, and of course, the population of that county from the census, and so can you weight the survey results because you know the true population there. So I worked, for example, on software to do that. Like, how can we make some tools so that the people in, say, the county office that had this survey, can we make some tools so that they could do the weighting and like see, okay, if this many people of this demographic breakdown gave us their answers, what can we estimate the true underlying population opinions would be on these things? So I worked on that kind of thing. So for me, moving from that kind of role to say that first more like in tech data scientist role, it meant way bigger data, way bigger data. I was moving from like data that clients could send to us in a spreadsheet to giant SQL databases, right? Like every person who has an account on Stack Overflow, like every question on Stack Overflow, like big, fairly like big-ish data. It also meant moving from honestly more sophisticated stats to kind of less sophisticated stats, like not doing as fancy stuff, like not doing it from a statistical method standpoint, and also moving from a place where it's like everyone in that, like everyone I worked with was a data stat sciencey person to more a classic tech company where it's like, oh, we've got product managers, we've got designers, we've got software engineers, and like, oh, what is it that I do here? Like how do I have kind of like a specific role? So I don't know that that's what all those kinds of transitions tend to be like, but for me and the particular like kind of place I was and I moved to, those were the like really big things. Also when I was in that little consulting agency, I was not a part of the business that was like, we need to get business. Like I was not in the let's go and gather clients part of the business. I was in the do the stats kind of part of the business. So, but certainly that also felt like a big change. It's like we're not trying to generate clients or keep clients or anything like. It's like, well, here we are doing it as the in-house data team or something like there at Stack Overflow.
Earlier, you mentioned writing a book, and I wanted to know, so you probably already had experience writing academic papers, scientific papers before. So how did that compare? Is it something that you written other books, or is it something that you would want to do again? Or like, how was that experience?
Yes, so I have published 3 books now at this point. So 2 on text analysis and 1 on machine learning. So 2 with O'Reilly and 1 with Chapman Hill. And it's I think that what is similar to the academic writing? I think that, well, okay, so I think something that is similar is that there is a normal voice for whatever that genre is. It's not the same, but if you think about an O'Reilly book, it like has a set of expectations around the genre, and certainly that is true also of like journal articles that you write. So I think that's something that's similar is that like, oh, okay, let me learn the rules and norms of this new sort of kind of writing, and like let me come and now show up and do that. I think that I like writing technical books because it is about people's real workflows. Like, how do people approach what it is that they're trying to do? Like, very much about the systems we use to work, very much about this very applied work, but about the tools, or about the process, not only just doing the applied work, but like, how do we think about how we approach applied work? So that I think is something that I really like about that style of writing. I'm not currently writing a book. I certainly would again. It is not the most lucrative way to spend your time outside of work in writing such books, but I will say it definitely opened career doors for me, like it definitely brought me opportunities. It definitely helped people take me seriously, like writing these books and publishing these books. No, writing books is not like quit your day job money. It's like remodel a bathroom money. You know what I'm saying? Yeah, it's not nothing. It's not
Yeah.
nothing, but nobody's quitting their day job to write these kinds of books.
So switching gears a bit, I think we'd love to hear a bit about what you're doing today in your current role, current company, and how that's going.
Yeah. So I've been at my current company for about 5, 6 years, 5, 6 years. And so this company the name of it is Posit, and it is a company formerly known as RStudio. So if you have ever used the RStudio IDE, it is the company that made the RStudio IDE. And if you have ever dabbled in R at all or like have heard of the Tidyverse or have heard of ggplot2, it's the company where the people who make those work. Work. So it's a company that makes open source software for data science. And the reason that we rebranded a couple years back is that for a long time, our company has made data science software in general, not just for R. And it turns out people don't believe you if the name of your company is our studio. So
I
they we re
always I always wondered what triggered that name change, and it is totally reasonable. Yeah,
Yeah,
yeah.
yeah, yeah. I mean, it's a tough thing to give up because the name Our Studio has a lot of name recognition. People feel very positively about the RStudio IDE. Many people, not like people like us who came up through astronomy, but if you came up through like life sciences or something, you almost certainly got exposed to like RStudio as a student, and people really like it. Like people really like it. So it's a little bit of a tough pill to swallow to be like, nope, we're getting rid of that name for the company. But it just was such a blocker to people taking us seriously outside of the R community. And for a long time, the stuff that we've made has not just been for R. And so it's a slow process of building back up a recognition of a name after, like having a good one. So when I first came to then our studio, I did work on R stuff. I worked on R, on software in R for machine learning and statistical modeling, like open source software for machine learning and statistical modeling. And then I shifted. So that was really fun. That was great. That third book that I wrote then. It's a book about, it's called Tidy Models, like kind of similar to the Tidyverse, but for modeling and machine learning. So that was the third book I wrote was then. I then shifted to working on tools for ML ops, for like deploying models. And that was both for R and Python because we had this vision of I mean, I did a lot of like user research actually with people who are our paying customers and open source users. Like, what is the blocker, both in Python and R? Like, what are the blockers to you getting your models deployed? Like what systems do you have? What have you tried to use? What do you do and don't like about what you use now to deploy your models? So we built a set of open source packages for R and for Python that have a really similar interface. They are meant to be Python native or R native. Like they're supposed to feel good to like someone who is a Python user and R user, but they actually have very similar APIs. And we really tried to align the APIs with what are the tasks people need to do? Like what is it that people actually need to do if they've finished training a model and they're like, it's done, like what do I do with it now? Like what do I, and like we kind of had an opinionated take on like what are the things you then need to do, and can we make tooling in both Python and R, for example, to version your model artifact and have like be able to have some nice tooling around metadata of like, okay, then that goes together. And then maybe can we go fluently from that thing to depending on your deployment target, either let's say in the most generic sense, like a Docker file and everything you need with a Docker file, like let's generate all that code. So a lot of kind of like meta programming, like a lot of code generation kinds of things, a lot of interfaces to different kinds of models, like on the Python side, it's like it's not enough just to support scikit-learn. And we didn't want to say you can't come to us. Like we wanted the situation to be like you could come to our set of tools with a model you've trained in a whole variety of different ways, right? Like if it's tidy models or scikit-learn or like all you can come in, and then we like if the model is trained, that's where we come in. So that set of tools was called Vetiver. It was really interesting to work in at a little bit more of the like not so much the stats piece anymore, but like the operationally, oh dear, the ops side. Let's say the ops side of like what do you do with your model once you have it. And so worked on that for a while, and that was really, and kind of when that was solidifying, some people at my company came to me and said, hey, we're building a new IDE. Do you want to work on it? And I was like, yes, I do. I do want to come work on a new IDE. So this was, at the time, it was a private project. It was not public at the time, but it's been really interesting. So I've been doing that for about the last 2 years, is working on this new IDE. And it is, if you're about to ask me, are you really making a new IDE, Julia, or is it another VS Code fork? I would say, correct, it's another VS Code fork. So my company has also forked VS Code along with like everyone else, apparently. definitely. But we're specifically making an IDE for data science. So an IDE for data science based on VS Code. So if you are someone who has used VS Code for data science and you've been like, well, I kind of get this extension and this extension and this extension, I kind of like cobble them together and it works okay, but sometimes it's like a better fit if you're more on the software engineering side and a little bit less good of a fit if you're more on the exploratory data analysis. If you're like, oh, I wish I had a notebook, but I could like see more about like what's going on in my notebook. If you were to draw a line from our studio to VS Code, this IDE, which is named Positron, exists somewhere on that line between VS Code and our studio. It's very informed by my company's experience building our studio over the last 15 years, very informed by that. I feel like people at my company know a lot about the work of data scientists, like know a lot about how data scientists work, what they do, how people who do data, like data analysis, machine learning, how they're different from people who do straight software engineering and how their tools should be different. So that's been really interesting. So Positron was made public like last summer. So we came out public. It's currently in a public beta period. We're planning on coming out of beta later this year. So yeah, so I've been doing that. So when I came to then our studio, my title was software engineer, which was very interesting as an identity thing. Like, wait, is that really what I am? Weird. Okay. And then kind of over the time, I've been taking more of a leadership role. And so technically now my title is engineering manager and I lead the team building Positron.
So we've had a few people before who made a switch from individual contributor to manager. And it sounds like yours may have been recent with this current position you're in now. Can you tell us more about that switch and how your workflow may have changed? I've also noticed that you've given lots of talks at different conferences and so forth. Do you think there's something related there, or is that just part of your personality and how you like to contribute as well?
That's a good question. Yeah. Well, so I think I've been in a management role for 3-ish years now, or something like that. 2-ish, 3-ish years now. And I think that I do sometimes miss the dopamine hit of being an IC. Because I think there's a lot more of the feeling of like, I solved the problem. Check, doing more management work. It is much more rare. It is much fewer and far between that feeling of like, I solved the problem because the problems are more about like a system and a team. I think that one of the things I like about doing more management is I really do love thinking about a complex system and how does it work together to have like an excellent experience for people or something. And I think it's why I liked, like, if I go back to the ML ops projects, right? Like I really found that very fulfilling, very interesting because it's a complex workflow that kind of like there's different options that people might want to take. And I like thinking about the system as a whole and how do we make that system work really well for people. One of the reasons I was very excited to start to work on Positron was because it is quite a complex thing. It's like take VS Code and then absorb all their complexity and then let's add some more because we're making a slightly different thing. And like, how does this all fit together? Like, how does it fit together? How do the pieces fit together? So I'm not someone who is at my most happy when I just go super deep into a narrow topic and just become like a huge expert on this like very narrow topic or spend my time getting to some solution there. That's not necessarily my favorite, most fulfilling thing to do. I do find it quite interesting to have a like a whole system view of something and to be able to understand how the pieces fit together and how we can like which are the pieces that need the most help right now and like how can we improve that. For me, I think why dealing with teams has been a good fit for me is that there's a lot of that same exact thing happening when you work with a team. It's like kind of a complex system that's all like everyone's all working together, and which part of that system is doing well right now and which part of that system do we need to think about, like what needs to be changed where. So I think that I like the work of management for much the same reasons why I have thrived in certain kinds of projects there. I do think that it is, I think interpersonally more draining. In technical communities, I am perceived as like just a real people person. Just a like, like, oh yeah, Julia, she's so good with people. She's so good at talking with people. But if you were to compare me to the population as a whole, I 100% am not. Like I am totally not. Like I am actually pretty introverted, like very introverted actually, and it's only in this kind of subset of of a population that I'm perceived as like, oh, so warm, so caring, so it's such a such a people person. And I do find it's like, oh wow, that takes a lot out of you, like in terms of dealing with human beings bringing who they are to work, because that's how it happens, right? Like we all bring a lot of who we are to our work and how we deal with each other and whatnot. So I would say that I do find it quite interesting, quite fulfilling, quite challenging. I could see myself swinging back to an IC role at some point, depending on the project and how things go. And that is something that people at my company do. Like people will move into management. It's definitely not a place where it's like up or out, or like you just have like you choose one time and you're committed now. That's your career now. Like people at my company, and I think at other companies as well, will shift into a more management centered role. Will shift back to a more IC role, back and forth. It's interesting talking to you two, given the background that we have. One of the things I really had a lot of sort of like heartbreak over at the point of exiting like academic astronomy was like, this is forever. This is forever. Like once I leave, I'm out and there's not really a path back in. And I am really glad now to feel like I have a lot of choices. Like I could, if I decide, in like next year, it's like, this has been good managing, but I'm ready to go back to an IC role. Like I could do that. I could do that for a few years and then I could shift back in. Like I'm really happy to be in a place where it's like, I have options that I think will be able to fit where I am and what I need, or like what I'm wanting or needing, or the different, like what do I want to get better at, like what is it that I want to get better at over time. I'm really thankful to have that kind of flexibility, I guess, in terms of the focus of work.
Yeah, I've personally switched between, manager roles and IC roles a couple of times. And yeah, the first time I went from manager to IC, yeah, I don't know if this was the academic background or something, but it felt, it was a promotion. It was a move up and lateral, but it felt in some ways almost a demotion. But that was just a weird mental thing of
Yeah.
myself. Like that was definitely not true. And I had more but different responsibilities, right? So that was strange. But the ability to do that either within a company or from role to role, company to company is certainly, I think, one of the things that people find very positive and very attractive about roles in industry, specifically, sort of tech data, kind of roles. So we're getting close to the end here. One thing that we always ask everybody, and I'm very curious to hear sort of your opinions on an aspect of this, but if you're giving advice to folks that are coming from an academic physics astronomy background, looking to get into tech, data science, software type roles, what are some things that they can do to prepare? I'm imagining you have some strong opinions on tooling and platforming and things that they might want to learn or practice with. But would love to hear, sort of what is your advice to folks looking to get into that?
Yeah. That is a great question. I am going to caveat this with I have been out so long that is
Fair, fair.
um so I'm going to caveat it, but I have recently hired some career changers. And so I'm like, oh, what was compelling about those candidates? Like as like, I'll be honest, I actually think I have a little bias towards career changers. Like I see someone who comes from, and I'm like, no, look what they showed. They're flexible. They can learn. Like I literally do feel like I think that way. And I've heard myself say that in like hiring panels when we're like discussing candidates. I'm like, but that person, they're a career changer. Look at all the great things we know about them. So that, I mean, I don't know. I don't know how commonly held a belief that is, but I really do hold that as a belief. My perception is we are in a much better place now than, in the year 2005. If you are in grad school now, spend your time getting good at transferable open source tools. Do not, I mean, like, back then it was like IDL and IRAF and all that. I'm like, do not spend your time getting good at IRAF and IDL. Like spend your time getting good at Python, like spend your time getting good at using tools that are open source transferable tools. I think if anybody is out there still trying to convince grad students, like if any old professors are still out there trying to like convince their grad students they need to use some like proprietary tool, I'm like, you are doing a disservice. You are doing a disservice to that student by like being like, no, in my lab we all use IDL or whatever. I don't know, whatever it is. So I'm hoping everyone is doing a little bit better on that than in the year 2005. I also think that building up modest experience in things that are to the software side. For example, being someone who can package code, like you can build a Python, like sure, you have these functions that you use in your project, being able to, even if it's for yourself, like build a Python package showing, and then that you can then deploy it. It's like package, people can install it from GitHub. Being able to do that shows, like that's also, I think, a super strong signal. If I see someone who has done it, not necessarily that they've like put it on the big package manager, but like if you can install and run a package from GitHub that they made, I think that that's like a very strong signal that that person is able to learn the kind of the ops side of the skills that are really important in industry. I mean, related to that, like being someone who has competency when it comes to Git and GitHub, like the being able to use that. And that stuff will help you in your own project. So like just even if it's no one's making you, like get good at that kind of thing. I think that like something that's just like I can't do anything, like someone who has no public code. I'm like they're like we can't hire that person. Like we cannot bring that person in for an interview. There needs to be public code that people can look at and understand what it is that you're doing. And then I think so some public code at all, and then some evidence of the communication piece, because honestly, it's like all day, every day, like that is what we do. That is what we do is like communicate about data, about the plot we made, about, and so I think that some things I've seen people do that I find quite compelling is being able to having talks online somewhere. And I think that I've seen people, whether that's, you giving a talk at a local Python meetup, or like submitting, if you make that Python package and then you submit it to SciPy or something and you do a poster and it's like, no, I can go and see the poster and like hear the person talk. So there's the speaking piece, which I think is very compelling on the job market, and then the writing piece. And so I think that blogs are really valuable. And I think if you're thinking about putting together portfolio or blog like putting something out there, I think that the very important pieces of it are that iterative back and forth. Like imagine if it is a report that someone is going to read, right? Like that sort of like narrative code plot, like that kind of thing, where people are like able to see the thinking, explaining like how did you approach that project. Like that I think is another piece that is very helpful for trying to like sift through applicants, and especially someone who's coming from, not from a master's in data science, but from like say like a grad school in astronomy. Like, what are the things that you can look at and be like, ah, no, this is compelling. This is compelling. I could see this person coming and doing what I what we need done here. What we need done here.
So one of the talks you gave at a conference recently at SciPy 2024 was about scientific computing across languages. Would you like to speak a little more about that?
That was very fun. So probably from what we've talked about so far, it's not a shock that like I spent a good chunk of my data science time like in the R community, and I do build tools for both Python and R users. Positron is for both Python and R. Quarto is for like Python and R and Julia. Like Vetiver, the MLOps tool, was for Python and R. But it is fair to say I am largely associated with the R community, like in people's minds. The books are mostly about like R. So I was invited to speak at that conference because of that sort of, oh, you're an R person, but you dabble in Python. Come and talk to us about that or whatever. And I was excited to come. I was expecting to feel like an outsider. Like I was expecting to feel like, though this is not my place. And actually, it 100% did not feel like that. And it was because it has been 20 years since I have been in a room with so many astronomers. It's like so many ex-astronomers there. So many. And I was like, oh, all the ex-astronomers are here. They're here at SciPy. So side note, I highly recommend for the listeners of this podcast, I highly recommend SciPy if you can make it there. It was like a lovely conference. Like the community, the topics, like a delight, a delight. So I was a little nervous about going, and it ended up amazing. But I was really glad to kind of talk about this issue of like what are what does it mean to build tools that work in different languages? What does it mean to build tooling for people working in different languages? So in grad school, I did all my coding in C, like vanilla C, like not even like C, C++, like C at the time. Like I wrote data analysis code. I used this like library to read FITS files. And I'm like, let me go find the C library that reads FITS files in and out, like it was, I wrote everything in C. And then when I was kind of doing more random things, I did things with various like front end kind of technologies, which I was less my thing, I think, like the sort of interactive front end technologies. And then when I was like, time to transition into data science, I originally just picked up Python because I knew about it. I'd actually had literally never heard of R, like literally did not know it was or that it existed, and then got exposed to R. I was like, oh, I actually love this, because it turns out something I've learned about myself is that I am more of a functional programming language person than an object oriented programming person. Like I love the Lispy functional stuff. Like I love it. I love it. So I was like, oh, I'm loving this. Like I'm really loving this. But then I kind of like came around again to like, oh, if we're building these kinds of tools, we actually want them just for data science in general, not necessarily for a specific kind of language. So I think I am someone that has not used one language over the sort of arc of my career. And I think there are some real benefits to being someone who is a bit flexible. And I think that I see it often. My particular path is a little weird, but I do see people, for example, who might like come into Python and then maybe go down the stack, right? Like to Rust, or maybe people who come in at R, right? Because maybe they were like some kind of biology person, and then maybe go more to the front end because they become really interested in data visualization, and then they go to like the JavaScript and like go that, like I see these shifts as people figure out like a little bit more of what they want to do. And I think that flexibility or that openness helps our thinking about the problems that we want to do. It is interesting to try to pitch this idea to a Python audience, because I do think it is possibly maybe the only language out there that people hear that and they're like, I don't know if I believe you. I think I think I can use Python for everything forever. You're like, well, maybe they're right. Maybe they can, but they'd be happier if they, like went to a lower levels, they like maybe you'd be happier if you were open a little bit. So it's kind of interesting to think about that as someone who has gone through this path. As a tool builder, which was the other big thing that I talked about in that talk, it is also interesting to think about what are the differences in these communities, and what are the similarities, and how can we build tools that are about like the thing people are trying to do, not about how do things happen in like what are the class systems in our like it's like I don't want people don't care. I mean, some people care, but I think it is more people what people actually care about is like I'm trying to get something done. What are the tools that we can use there? So that was a really interesting talk to prepare and to give to that audience, and I think it's interesting to kind of like start it in Python, go to R, then kind of like be both now. And the in R, the package developer experience is quite onerous, but the user like install experience is like so smooth, so easy. In Python, the package developer experience like low bar. It's like you can do anything. But the user experience rough comparatively, like you're like I just even getting your packages installed, you're like why is this not working for me, like why is this like this. And then the other thing about that talk that was so funny to me is ever since I heard or read about the Zen of Python, I have been obsessed with it as like a statement of values, or like an aspirational kind of thing, because my perception of like my experiences, building packages, using things like in Python, I'm like none of it's true. Like none of it. I'm like there should be one and only one way to like what? No. I'm like I want to talk about it because I think it's just very interesting as like an aspirational statement, and like how have things played out in the Python ecosystem the way they are, given that there was like that it's like, oh, that's so interesting. And like in R, things played out quite differently, but not for necessarily good reasons. It's like, oh, just interesting. This is a little bit inside baseball, but I think I am fascinated. I am like fascinated by how these things play out the way that they do. Big picture, I was really thankful to get to talk to that audience and to be able to reflect on kind of like what is it like building tools for users with different expectations, but actually the same kind of needs underneath. So it was really great to be able to go there and give that talk.
Wonderful. Well, thanks so much for joining us today on the Astronomers Turned Data Scientists podcast. Please subscribe so that you can find out when we release future episodes.
Thanks for listening, everyone.
Thanks for having me.